Are we on 16?
Hi, this is group 14. I'm Bree.
Hello, I'm Bobby.
Eric.
And Rachel will be joining us in a few minutes. Okay, so we're going to take lesson 16 group quiz. Okay, we all in the quiz?
Yeah.
Opening now.
So if you go to question 3, the first one, in a pie chart, why are the slice of sectors different sizes? Obviously, because they each represent a proportion of the total whole.
So it's the third one, right?
That is a silly question, I feel like. Is that a trick?
No, because it's talking about different charts and how we interpret proportions, which is p hat. It's related. Pareto, if I'm saying it right, that's the one that's like bar charts are different heights
Yeah, so
all
it's
over.
kind of random.
Pareto is like a
Okay. It's
in
like
order.
an investment chart.
So like high to low. There you go. Yeah.
Bar.
Yeah, so the only difference between the bar chart and the Pareto chart is that the bars in the Pareto chart are ordered from largest to smallest, going from left to right.
Mhm. So an investment chart is not a Pareto chart, but it's basically because you're hoping to make it go up that way, not down.
We conclude that p hat is normally distributed if the sample size times p is greater than 10, or n times 1 minus p is greater than 10. Is p the true proportion or sample proportion? I want to say it's an inference on the true proportion. Okay, the estimator of p is p hat. So p is like the probability. So if you flip a coin 10 out of 50 times heads, you'd have whatever that is, 20%, something like that. That's the estimate. So it says the sample proportion p hat is 1 point on the number line that estimates the value of the true proportion p.
Okay,
So p hat is just kind of giving you an estimate. So p is the true proportion. P hat with the, yeah, p hat, that's all it's called. Learned that before. What is n?
P hat.
The sample size. N is always the sample size. Yeah.
They're trying to trick us with numbers.
Yeah. If p is 1/4, what is the smallest that n? What is the smallest n that satisfies the requirement? So it goes back to the reading. The formula. I think it's just the formula we just talked about. N and p have to be greater than or equal to 10. And n outside of 1 minus p have to be greater or equal to 10. So if p, what is the smallest n can be? So wouldn't you write this one out?
Is it 40?
Well, you wouldn't it? Because then, yeah, I think it would be 40. Because if you're thinking 40 divided by 1/4 is 10. Because I equal to 10. Yeah. So I'd say 40. Yes. That would make sense. Shouldn't be that difficult because it doesn't say round or anything, you know. Okay, suppose n is 24 and p is 0.4. What is the mean of p hat? So that's when
P hat equals x over n also equals,
I just can't find. I need to like just write down all the formulas.
Mean of p hat is equal to p
Where are you seeing that?
on 2.2.
Oh yeah, the mean of p hat is equal to p.
so is it just a trick and it's 0.4?
So if you're looking at the example below, what is the true proportion of heads? This is the mean of p. So p was shown early to be 0.05. So just so it wants you to understand what, your values are. What is the standard deviation? Yeah.
Second one is the same as ours.
The standard deviation. Okay, that one's a little more confusing. It's right underneath it.
Standard deviation of p p
So
hat
p
is equal to the square root
minus p
p times
over n.
1 minus p over n.
Okay, so let's get, so p is 0.04 times 1 minus 0.4 all over 24, and then you take the square root of it. So 0.4 0.6 divided by 24, 0.01. How do you take the square root of something?
I got 0.1.
0.1, yeah, that's what I got. And it's to the 10th, so that would make sense.
And should because we all rounded them, we should be good.
Yeah. They're definitely different.
It's one of the things about girl names is a lot of times they just spell them so different. Whereas
Yeah. Guys are pretty much
yeah.
simple.
Like, I mean, with John, I'm like, okay, you can take the H out.
Mm-hmm.
With like Eric, you can have K in there, which is just weird.
Yeah, it's a little odd. 24.
Robert. There's only one way to spell Robert.
Yeah.
Like Michael.
You can't really deviate too much from them.
Yeah.
You get 0.1 as well?
Mhm.
Okay, Brittany's batting average is 0.3. We want to determine the probability that she will get more than 35 hits in the next 100 at bats. So N is 100, P is 0.3. What is P hat? Point. This is round to 3 decimals, so 0.30.
This was 2 decimals.
Oh, excuse me.
Okay. For a second there, I was like, am I different?
No. What is the standard deviation? Okay.
So 0.30. For the P hat for 10. Round to 2 decimal places.
Yeah, I think 0.30.
Let's just try to trick us.
Well, because the batting average, they show it as 3. To 3 decimals. 0.3. Square root. I got 0.0458.
Me too.
You got that as well? So round to 3 decimals, 0.046. So that makes sense. What's a z-score? Okay. Okay, so it's the value minus the mean over standard deviation. So it's the same thing that we did before. So the value is the p hat. They'd be the same.
Are we? Okay.
Well, yeah, it says p hat is equal to p.
But
It says
the
it all in
mean
the
of
reading.
p hat is equal to p.
Well, let's see an example. Here we go.
What did you guys give her, 12?
Yeah, because, well,
Well,
Save 7, and 7 wasn't saved because I noticed it wasn't saved, and then I was pressing, and all of a sudden, like,
oh,
like, yeah, like the screen did that.
weird. Well, like if you look at example 3.3.1, it's talking about the like the coin tosses. So like obviously the mean was 0.5. That's your normal one, but your p hat in this one represents the sample proportion. So this one at this time they're talking about for this specific thing it was 0.68. But that's the thing. They're not talking about two different things. It's just talking about the p and the n. So it'd have to be 0.3 minus 0.3. Well,
that comes out to
Would
0.
be 0.
unless it says Brittany's batting, we want to determine the probability that she will get more than 35 hits in her next batting. So would it be 35 over 100? So it'd be 0.35.
Oh, 0.35.
Do you think it's that?
That would explain why it's 2 decimals, which,
Yeah. So it'd be 0.35 minus 0.3.
over 0.406.
The standard deviation, what did we get?
0.406.
Yeah. Then I feel like what is hat? I think this would be different. I think it'd be 0.35 for question 10.
Okay.
You know what I mean?
Yeah, I think so too.
And when you put that in 0.35 minus 0.30 divided by 0.046, did you get 1.0869?
Wait, so
These four?
I got 0.1 through 23, so let me just redo it.
Okay, so 0.35 minus 0.30 divided by 0.046. Yeah, I got 1.869.
I got 1.091. But I used the answer from before, so like I think mine might be slightly more correct, maybe, just because it was.
Yeah, but I feel like you would take what you've already rounded. Does that make sense? Since you've already rounded the standard deviation in question 11, you'd use the rounded one. You know what I mean? Equals divided by 0.046.
Oh, 0.046?
Yeah.
I was putting in 0.406. Problem solved. I'll have to figure this out.
And then we have to put, let's see if everybody, did you get the same thing?
Yeah, now it is 1.087.
Okay, that's what I got. So then we put this number into the normal probability applet. .087, and it's only greater than the area is 0.139.
0.139.
Yeah.
So.
What's the probability? 0.139. That's kind of terrible.
Okay, so what was the number?
When you put it in for greater than, it's 0.139.
So 14% chance.
Essentially. It's really quite sad. Okay, use for the next 3 questions. If the true proportion of people who support a political candidate is P is equal to 0.52 and 2,000 people are surveyed, we want to determine the probability the results of the survey will suggest that a candidate is losing election, getting less than 50% of the votes. What is the standard deviation of P hat? Okay, so it would be 1 minus 0.52 times 0.52 divided by 2. Okay, I got 0.011.
Me too.
Small number.
It's probably because of so many people.
Yeah, that's true.
The sample size is large.
What z-score would you use? It's kind of a weird way of phrasing it. You know what I mean?
Mm-hmm.
It's at 0.011.
1. That's the 3. Okay. So we're 50% of the vote. So we point. So if you're doing the z-score, 0.50 minus 0.52, which is your p, divided by the standard deviation is 0.011. Ooh.
So you
Can it be
use the
negative?
negative version of it.
Okay. Oh. Okay. So I got negative 1.818.
1.828. Okay.
Negative.
Oh, yes, negative.
Negative 1.81. You put that in.
1.818.
Negative 1.
Which ones are filled in?
It's less than 50, so it should be everything to the left. So point.
0.9.
What? No. It's the negative, so you have to start at the negative and down.
Okay.
Yeah.
Okay, so 0.0345.
Yeah.
0, 3, 4. What?
0.03. No, 35. Yeah.
Okay.
Okay, I'm gonna submit. See how we did. Oh, 100%. Yay!
Right.
When we really understand it, that is such a good feeling. Okay.
Well, next